Hey guys, here's the last two parts to our course. One is called the law of sines, and the other one is called the law of cosines, which my next video will be on that. This is section 6.1 in your textbook, and this is course 192. Let's just take it slow and look at this. It's not that complicated to use, as it is a little bit complicated to see where it came from. But we want to find missing sides of triangles that are not right triangles. So I just drew one here. It's not a right triangle. We call this an oblique triangle. There's no 90-degree angle in it. But since our trig equations only work for triangles that are right triangles, what we're going to do is we're going to make a right triangle out of this one and draw an altitude down here, and we'll call this h for the height of that triangle. And then we want to take a look at the relationship between the sides, the angles, and that height. Well, if we were to say in this right triangle, say there's one on the left and one on the right. Let's say we're going to use the sine function. We say the sine of angle A would equal the opposite over the hypotenuse. And in this triangle, the hypotenuse is B. And then if we just solved for h, we'd have h equals B times the sine of whatever angle A is. So at least we know what h is in terms of angle A and side B. If we did the same thing for the other triangle, we'd say the sine of angle B is equal to the opposite over its hypotenuse, which the hypotenuse in this triangle is A. And if we multiplied A up on the other side, we would have A, side A, times sine of angle B would also equal h. So we have h equaling two different things. Well, if h equals this and h equals that, then these two things must be the same thing. So we'd have b times the sine of A equals a times the sine of B. And if we cleaned it up a little bit and divided both sides by A and divided both sides by B, we would get something that looks like this. The sine of A over A equals the sine of B over B. So what we're saying is the sine of any angle over its opposite side equals the sine of any other angle over its opposite side. This is really useful to us. If we drew the altitude a different direction and say we used angles A and C, we would get the same thing we could draw with just a different height going a different way, and therefore we would get the sine of C over C would equal, say, the sine of B over B, or the sine of A over A, depending on how we drew the height. So this right here, we find this is what we call the law of sines. And we'll take a look at how to use that in a minute. But if we wanted to find the area of such a triangle, usually we would have to know what the height is, and we'd have to figure everything out ahead of time, but we may not even know the height. But just knowing the dimensions of the triangle, we can still find the area. Well, think about that formula that you learned probably in middle school or maybe even 6th grade or something. The area equals the base times the height. Base meaning the bottom. This is the base or the bottom of the triangle, and the height being how tall the triangle is. So the base in our case over here is C. So we got 1/2 where the bottom of this triangle is C and the height is h, but we already know that h could be written two different ways. It could be written B times the sine of A. So this could be the area formula. We could also say that it also equals 1/2 of, we could use this one instead, A times the sine of B. It's good that we have different forms of this, so that depending on what information we're given, we could always find the area of the triangle. We would also, wait a minute, this would be A, so this would be C times A times the sine of B. And we could also say, well, what if we were given angle C instead? We would have C times A times the sine of C. So we'd have three different things, and just look at the one for a minute and see what sense this makes. 1/2 the base times the height, the base being C, the height being we're going to rename it in terms of the things that we know in case we don't know the height. We would call it b times the sine of a, and we got this by very simply using our trig formula for the sine function, opposite over hypotenuse for that triangle. And now we got a new formula for the area of any triangle that is not a right triangle. And we can use this several different ways. Let's take a look at how the law of sines actually works. And we can use our calculators too, which would help us out. So I'm given a couple different examples. And I want to find the missing parts to this triangle. If I wanted to find this side, which I'll call x, knowing that from our formula over here from the law of sines that the sine of any angle over its opposite side is equal to the sine of any other angle over its opposite side, we could use that information here to try to solve this problem. So if we try to do this, let me use a different color. I'm going to say the sine of 80 degrees over its opposite side is equal to the sine of any other angle over its opposite side. And in our calculators, if we just multiply both sides by x, we'll get x times the sine of 80 equals 10 times the sine of 60, and then divide both sides by the sine of 80. So we would get this. And if we put that in our calculators, let's do it together and see what we get. We're going to get 10 times the sine. Oh, by the way, you have to change in your mode. You have to go to your mode and hit mode and make sure degrees is highlighted since we're dealing with degrees now. But we got 10 times the sine of 80, and I'm going to, sine of 60 it should be. So that's 60. And then I'm going to divide that by the sine of 80. And we should get 8.79385. So this would be, x would be 8.79385. So if this were 10 inches or 10 miles or 10 centimeters, then this would be like 8.79 centimeters, that opposite side. This is what we call an angle-side formation, where we're given two angles and we're given a side that's not in between the two angles. The side is next to one of the angles but not next to the other one. If this is 80 and 60, that's 140 degrees. Subtract from 180, and that would automatically be 40 degrees. So what if we were asked the same question, but we were given different information? This would be an angle-side angle situation, because I have two angles and I have the side in between the two angles. Let's use the formula again and see how it works. So let's just say I wanted to find this side. I'm rounding a little bit, so it might not come exactly back to 10, but it should come close. So I'm going to go, well, let's see. If this were 40 and 80, we could put a 60 in here, and we could do the sine of 60 over its opposite side equals the sine of 80 over its opposite side, which is x. If you cross multiply and divide, just like we did up here, you'll see that x should come out pretty close to 10. So when you're given two angles, it's pretty easy to solve for the missing parts. If I wanted to solve for this, y, say, all I would do is I would go sine of 60 over this, and then sine of 40 over y, and I could find out what y is. And I could do the same thing for this. Once I found out what this is, I know that this is 40 degrees. If I wanted to find out what y is, I could do the same thing. I could go sine of 80 over 10 equals sine of 40 over y. And I'll get the same answer as if I did it this way. So you can see how these could be very useful in finding out the missing measurements of sides of triangles, even though you don't know what they are. Now let's do this. Let's say we want to find out what the area of one of these shapes are. And then we have three different area formulas we could choose from. But we could actually think through it. Let's see. We want to find the area, so we'll write it down here, the area. And I know it's going to be, look at this, whatever angle I'm using, I use the other two sides to find its area. If I use angle B, I don't know if you can see this, if I use angle B, I would use C and A. If I used angle A, if I'm given angle A, I would use C and B. If we were given angle C, I'd use, oh, this is wrong. This would be C, and this one should be B, I think. Right? A and B. Oh, no, this one should be B. What's going on here? So this one, I think I screwed this up because my letters were a little bit different than what the book had. So this would be angle, oh, no, this is right. Sorry. This would be AC with the angle B. And this one would be an AB with the angle C. So this would be an AB with the angle C. So if you wrote that down in your notebook, correct it. So if I'm using angle A, I could use sides B and C, not the side that's across from angle A. If I'm using angle B, I would use sides A and C, the two sides, but not the one across from B. And if I want to use angle C, I would use A and B. So correct that in your notebook. Let's see if we can make it work here. So let's say I want to use, let's see. By the way, if we did find out y, we might as well fill them all in. So we know that this is about 10. And if I go sine of 80 over 10, let's find this side y. We'll put it up over here, I guess. We're going to go sine of 80 over 10 has got to equal the sine of 40 over y. And if we cross multiply and divide again, so we're going to go sine of 80. Do it in your calculator as well. Or sine of 40 times 10. And then we're going to divide it by the sine of 80. And we should get, for this side, 6527. We'll carry out a few decimal places so we have less error. Now think about this. The largest side is across from the largest angle. The medium angle has the medium side, and the smallest angle is across from the smallest side, right? So if we want to find the area up there, what angle do we want to choose? Let's choose the 40 since it's on top. So if I do sine of 40, it would be 1/2 times the other two sides, which would be our 10 and our 8.79, we'll call it that. This would give me the area. If I wanted to choose the 60-degree angle, and it all depends on what you're given in the problem, I would go 1/2 times the other two sides, the one that's not across from the 60, so that's the 8.79. We're not going to use that one. We're going to use these two, which this came out to be 10 and 6.527. So this would be 10 and 6.527. I could also use sine of 40, which is this one. So that means I'm not going to use that side. I'm going to use the other two, which will be 10 and, I did 40 already. Let's say I want to do sine of 80. So I'm not going to use the 10. I'll use the 8.79 and the 6.527. I'll use those two, take 1/2 times the sine of 80. So I would eat any one of these, I would give me the area. And it all depends on, in the problem, what they give you. They may only give you one angle, so that's the one you got to use. To get the area, you would use the other two sides. The problem with this whole process is there's one situation where the formula breaks down and it doesn't work. Let's see. This one is called the ambiguous case, and we'll just go over it slowly. And a good way to remember the ambiguous case is that it spells a bad word, angle, side, side. So let's say we were given this angle and we were given these two sides. In this triangle, we could actually draw another triangle if we were to move this side B, and we just same size, we're not changing the size of it, and we moved it over here. we could actually have two triangles, this bigger triangle and this smaller triangle. That's actually an obtuse triangle because it has an angle bigger than 90 degrees in it. We could have two triangles that have the same measurements, the same B, the same A, and the same little b. As this triangle, the big one, angle B, A did not change and B did not change, and we get two triangles that are similar to one another. They're not similar. They have the same three pieces of information given, but yet it could give us two very different answers. So if we were looking for, say, let's say this is side C could be here, or side C could be the whole thing. How would we know the difference? Well, we're running on about 16 minutes in this video, so we're going to pick this up in our next video. But in the meantime, I want you to practice some problems from section 6.1, and I'm going to ask you do as many as you possibly can on page 720, and start with number 1. You could do the odd ones, and you can try all the way up to number 37, and try as many as you can. Our next video is going to be more about this, and then we'll go into the law of cosines. So your quiz will be just on the law of sines. Remember that this situation doesn't work, and I'll send you another short video on that real soon. Talk to you soon. Bye-bye.